Hey guys, welcome back to another video. Now this video, I'm not actually gonna sort of walk through all of kinetics. In this video, I'm actually just gonna focus on solving AP style problems, specifically multiple choice problems, and just like go through my thought process and stuff like that. So this is one of the problems, basically saying consider the following reaction: 3A yields 2B. Compare the rates of appearance to disappearance. So they give you this relationship, and you have to find out what this coefficient is. Now, this is actually a pretty basic problem, but it can be pretty confusing. So just know that if you have like a reaction in the form of this, then the relationship is this. So basically what I'm saying is these rates are the same, so the rate of production or appearance of B is proportional to the disappearance of A based on these coefficients. 1 over the coefficient of this, and -1 coefficient of A. And it's negative, remember, here because this is disappearing. The reaction is going this way. And B is appearing. So if you see here, it's actually pretty similar. So basically, how we get this answer is we multiply both sides by B. So we get negative B over A dA dt equals dB dt. Except you really have to pay attention to the sign here, because there's already a negative here. It's just B over A. So based on here, it's just 2 over 3. So the answer is C. So the next question I have for you is a graph below depicts the relationship between concentration and time for the following reaction. What is the slope? Now the thing with this question is that the actual reaction, or like the 2A yields C, isn't really important at all. The very valuable information we gain from this graph is the fact that when we vary the concentration of A, or the natural log of the concentration of A and time, we get a linear graph. And this tells us that this is a first order reaction. Now that we know that it's first order, the slope for this graph is nothing but the rate law that we know, because it's a first order reaction. And this is something you should sort of memorize. But so this is actually kind of like y equals mx plus b, you know, where t is x, b is ln of the concentration of A not, or at 0, and this is at t. So we know this is ln A0, and the slope is actually negative k, and we know this through the rate law and the fact that we know that it's first order. So the answer is actually A. Obviously we could do a lot of process of elimination, because it's a negative slope, right? So it can't be D or C. So it's just something to think about. So in this next question, it says that um, it asks, what is the rate constant for a first order reaction with the half-life of 225 seconds? So it's sort of like a tip I'd like to say just for these types of questions, like knowing what to do when. Um, a half-life is essentially half-life. It's the amount of time it takes for a concentration to half. So from 2 to 1, uh, 6 to 3, 1,000 to 500. It's the amount of time a concentration takes to half. And anytime we see a concentration decreasing or increasing, a concentration changing, and they give you a time, that should immediately scream that it's some sort of rate law. And we know that because it's a first order, we can already sort of write this down, that right? So now the thing with half-life is all this is based on log rules is this. Oops. What was I doing? In half-life problems, this ratio will always be 1 to 2, right? Because if this is, let's say this is originally 6 molarity, and for half-life, for it to half, it becomes 3 molarity, right? So 3 divided by 6, it's always going to be 1/2. Now if this was like 1,000 and this is 500, I'm talking about the concentrations, it's still going to be 1/2. The ratio is always going to be 1/2 for a half-life, right? Makes sense. So all this is asking is ln of 1/2 divided by negative t. And in this case, because that's 225, ln of 0.5 divided by negative 225 is 3.08 times 10 to the negative 3. Now, this actually sort of gives us a segue for more like sort of observations we can figure out about half-lives. For half-lives, it doesn't matter what your starting concentration is, what your ending concentration is. None of that matters. All that matters is sort of your rate constant. That's all that matters for finding a the half-life, or T, for a half-life equation. The starting and ending concentrations do not matter. For this next question, they're asking which variable corresponds with activation energy for the forward reaction. So all activation energy is, for a energy diagram like this, it's the difference in energy between the reactants and the activated complex. So for instance, these are reactants and these are products. And the activated complex is on this top sort of hump. And the difference is X. That's all that is. Now, the really interesting thing is, so this is a exothermic reaction, right? Because energy is being released. It's the difference between here and here is negative. So, now what if we have an endothermic reaction, right? And that's X, and then this is Y. And that's the energy. That's the reaction pathway. The activation energy based on my same definition before, would actually just would be x plus y. Just because the reactant energy is lower, right? So it has to incorporate both, because it's the difference between the reactant energy and the activated complex. And in this case, because it's switched, it's x plus y. So this is gonna be the last problem. It's a fairly long sort of problem, so I'm gonna go through the entire sort of process. So this question is asking us what the entire rate law is. So basically they're saying, actually, should use a different color here. Rate equals K they want us to know what m, n, and what the actual rate constant is. Now, when we see this problem, we're sort of tempted to put m and n as 2 just because the stoichiometric coefficients are 2, but that's wrong, because to find the rate law, it should be done experimentally. And we're given data, so we should just use that data and actually find what the orders are. And the good way to do this is to it's hard to explain completely, but I'm gonna show it to you here. Let's say we want to find this order m first, okay? So what we're gonna do is actually divide two rate equations, and sort of eliminate two similar answers to get what we're looking for. So if we want to find m, we're actually given two experiments, 1 and 2, where the hydroxide are the same. So we can actually eliminate hydroxide to get one variable and actually solve for it. So let's do that. So 0.0248 equals K, which we don't know, times 0.060 m and 0.03 n. And we divide everything by experiment number 2. So this is experiment number 1. Let's do number 2 now. Okay, that's 0.00276 is equal to K, 0.020 m, 0.03 n. Sorry, it's kind of cramped there. So let's delete or sort of eliminate the stuff that we can. This is a rate constant, so because it's the same regardless of the concentration, this can be eliminated. We did this on purpose so that we're only left with one variable. So we get 0.0248 divided by 0.00276, which is actually 8.99, so it's like around 9, equals 0.060 to the m divided by 0.020 to the m, which is nothing but 3 to the m. So that's around 9 basically. So we get that m equals 2. So let's go ahead and replace that. So we know m is 2. Right? So let's do the same thing with n. It's the same process because now we just used experiment number 3, where we can eliminate the m variable. So in our case, so remember how the last time we kept these constant? So now we're going to keep these constant. So we're going to compare number 2 and number 3. So we can delete m and just get n, and we can solve for n. So let's do the same thing that we did. 0.00828 is equal to k 0.020 m 0.090 n, and we divide this by 0.00276 equals k. Same, so we're just doing number 2, number 3, and number 2. Uh, 0.00030 n. So something very similar. These can be deleted. These can be deleted. 0.00828 divided by 0.00276 is about 3, and we get we simplify this, we get 3 to the n, so we get n as around 1. So a big chunk of our answer is done, but we get that is our rate law for now, but we also want to know the rate constant. And now that we know the actual orders, we can just plug in one of the experiments. It doesn't really matter which one. You're gonna get about the same answer. So you know that let's use experiment 1. We get like k times 0.06 squared times 0.03 and we can solve for k. So I'm gonna do that right now. So I solved it and I got k. We get k is equal to 230. That's our k. And that's our rate equation, where the overall order is 2 plus 1 equals 3.